squares. We can't find the right place to be. Here we go. Who asked over there? Parker? Once again, it's strongly recommended, you grab yourself a piece of paper, jot yourself some down. No, it's what we say, 19?
Yeah.
Number 19. Well, I can't really help you too much on there except to tell you what rules we follow. What's the easiest way for finding the square root of a number? Step number 1 is to prime factorize. There are other ways, but if you don't get it, this is the way you probably should do it. Which means you need to break this down, and please don't get lazy and not write the square roots down. 3,600, what times what gives you that would be the logical answer. What's that?
100 times 36.
Yeah, the square root of 100 times the square root of 36. What times what gives you 100? The square root of 10 times the square root of 10. The square root of 36 is the square root of 6 times the square root of 6. And at any point, you see those things there. You got doubles here, what happens? They cross off and you get a normal. You got doubles here, they cross off, you get a normal. 6 times 10 is 60. That is the square root. Now you could have continued to break this all the way down. You will still get 60. You will still get 60.
I did 40 and 90.
Oh, here, I'll do 40 and 90 for you. 40 times 90. 40 breaks down to?
I put 22.
Square root of 20 times the square root of 2. Square root of 20 breaks down to?
10 and 2.
Square root of 10 times the square root of 2. 10 breaks down to?
5 and 2.
Square root of 2 times the square root of 5. 90 breaks down to?
32.
What?
Oh, that's what I went wrong.
Yeah, square root of 30 times the square root of 3. And if you make a mistake on any of those places, you're going to end up. Cartwright.
Answer to 6.
The answer to number 6 was about 144 inches squared. Want me to do number 6?
No.
Brant?
Maybe it was 10.
Is that on this page or the one before it? 10. Yeah, here's one. Please understand, children. You have to see the difference between, Evelyn, when they ask you how much it increased or what it was of, the area of. And here's what you do. Remember, since we're doing this percent thing, okay, this thing is increasing, right? You've got your original, it increases, and then you've got your final. When they ask you what percent of the area, you're looking for this one. When they ask you how much bigger it is, the percent is what bigger, you're looking for the plus number. So when you did this, the sides of the square increased by a scale factor of 2. It doesn't tell you, so you just pick what do you want to make your first one? Alright, so 10 by 10, scale factor 2 means the new one is what, Brant? Huh? Huh? No, what's those new dimensions? Scale factor 2, 10 times 2 is?
20.
Right, so the areas are 10 times 10, this is 100. 20 times 20 is 400. Now, what we know is this. Okay, we know the original percent is 100. We don't know either the percents, how much it went up, or the final percents, but we do know all the area stuff. Original area is 100, which is good because they match up. The final area is 400, so it increased by 300. Now the beauty of this is if you picked 100 here, all of these are going to just be the exact same because, and they asked you for what percent of the final is, and that's where the 400 comes from. 300 was by how much it increased. 400 is what it is. Okay, why? Because what do you multiply 100 by to get 400? 100 times what is 400? 4. And what is 4 as a percent? 400%. It is 400% the area of the other one. It's not 400% bigger though. It's 300% bigger because you're asking how much. This is the bigger number. This is the of number. thought that was so exciting. So be careful with that. Odds are probably tomorrow they'll ask you that same question. So when you do the box, odds are this is the answer you're going for. That's why you would jot a note to yourself. Dear self, please note.
Wait, so the answer is 400?
Huh?
The answer is 400.
No, it's gonna be the same type of question.
It'll be that box. They won't be those same numbers.
No, for this problem, the answer is 300.
No, for this problem, the answer is 400. Because we wanted this number. I said if they ask for increase, it would be this number, but it's not. Tomorrow they're going to be different numbers. You can't just. I would write just 400 there. Odds are it's probably not going to be the exact same.
Yeah.
Wait, Davis.
How do you do 17?
Oh, I was hoping about number 17. Now, I couldn't help but Carter Westfall, you said you got 1.4, and I don't get how that happens. Where does that come from? Did you just guess? I don't.
I did the problem.
What type of problem is this? We are doing, first of all, it's in scientific notation, and it's either a multiplication or a division problem. What is it? It is not multiplication, it's division. It's a fraction. A fraction is a division problem. Step number 1 is to divide the left, which means you divide this. How many times does 2 go into 1.2? You get 0.6. And right away, children, 0.6 should, all sorts of warning signs should go off 0.6 because in scientific notation, you're not allowed to have a 0.6 as part of the answer. So in the end, you got to fix that, but we'll worry about that later. Step number 2 is to write down times 10, because we're keeping it in scientific notation. What is step 3 with division? Amelia? What is my third step here? I divided this, I wrote down my times 10, then what do I do? I still got to deal with these things right here. What do I do with them?
In division, you subtract.
In division, you subtract, and you are subtracting the bottom from the top. If it was multiplication, you add. Here, though, you're taking 5, and what are you subtracting from 5? Negative 2. 5, 2 negatives together do what? Become a positive. It's actually 5 plus 2. And I mean, we are subtracting, but you're subtracting a negative, which is actually adding. So I end up with a 7 here. If you got that, your answer is still not right, like I said, because it's not in scientific notation. Subtract exponents. How do I fix it? Where does the decimal have to go? It has to go here, so it becomes 1 and 10, so I have 6. If you think about this as like being a balancing thing, I made this number 1 decimal place bigger, I need to make this one thing smaller. 6 times 10 to the 6th. Again, tomorrow's probably going to be very much like that. You know, there's a chance that you won't have to move the decimal, and this will be between 1 and 10 to start off with. I don't know. I mean, don't write down that. I mean, you just got to do it case by case. Evelyn?
11.
Number 11. Is that up top here? No, it's over here somewhere. Up top over there. Number 11. 2 unimultipliers of square feet to square yards. Why do I need 2 unimultipliers? Somebody, give me the reason. Why is there 2, Amelia?
Because you have to write 54 feet times feet over 1.
Right. It's not 54 that's being squared, it's square feet. It's 54 feet squared, which are 2 labels of feet. Area is feet times feet. Oh, how many feet you need? Can you look? Dr. Seuss, the footbook. So you need 2 unit multipliers to cross off with each of these labels of feet. If feet are on top, they're going to end up where, Brant? On bottom, because labels are looking to cross off. I'm changing feet into, so that has to go on top. It's my only place left. And then I have to know the conversion from feet to yards or yards to feet. What is it, Amelia?
3 feet equals 1 yard.
3 feet is 1 yard. And then you just do the little work. 1 foot, cross off with 1 foot, 1 foot with another foot. 54 divided by 3 divided by 3, which is the same as 54 divided by 9, which ends up being 6. What are you left with? Yards times yards, or yards squared. 6 yards squared. Will it be feet and yards tomorrow? I don't know. Maybe the 3s will be on top tomorrow. It all depends. But it's a foolproof way of changing stuff. You can't go wrong. Just crossing off labels. Even Wade realizes that. Those are the only ones you got missed. Wade, did you miss any other ones? Did you wear sunscreen?
Yes.
Are you burning or peeling?
Florida, I did wear sunscreen.
Coincidence? Abram!
What was the answer for
5 was 3/5. For Westfall?
I get 1 and 2.
1 and 2. 1. 3 out of 4 doctors surveyed recommended the product. 60 doctors surveyed did not recommend the product. Did you draw a ratio box?
Yes.
Alright. What info do we know? What are we comparing?
We're comparing 3 out of 4
No. What are the things? What did these doctors?
surveyed and not surveyed.
No.
Recommended.
Everybody was surveyed.
Recommended and not.
Okay, so you have some that recommended, you have some that did not recommend, and then you have your total. Did you have all 3?
Yeah.
Alright. How many recommended?
3/4. Wait, 3 recommended.
3 recommended. How many total?
4.
So how many did not recommend it?
1.
Those are your ratios. 60 doctors did not recommend. 60 did not recommend. How many doctors were surveyed? I want total. I don't need this part of my thing. How do you go from 1 to 60? Multiply by Carter?
Multiply by 4. No, multiply 6 by 4.
Well, multiply 1 by 60 to get 60, and multiply 4 by 60 to get 240 total survey. And then number 2?
Yes.
Oh, percent is always what? Thank you. So let's start with that. A used car purchased a car for $4,000, sold it for 40% more. What should you do on this one? Percent box, just like the last thing. What type of percent is this? Increase or decrease? Did he mark up the car or mark it down?
Mark it up.
So that you have your original price plus the markup equals the final price. My original percent is always 100. Do I know how much I marked it up?
Yeah,
40% more. So my final percent is 140%. Do I know the numbers that I sold the car? Do I know what I sold the car for, how much I marked it up, or do I know the original price? Do you purchase the car? The original. You paid $4,000 for it. And then I want to know what? The selling price. So I need to figure out what this is, not how much you marked up, but the selling price. So 100 over 140 equals $4,000 over what number? Can I go from 100 to 4,000?
Yeah. Wait.
By what?
5.
Right. So I am to get my answer. I'm just going to take 140 times 40. 0.006 $5,600 for a cool profit of $1,600. $1,600, kids. Money to be made in the used car business. Carter.
How do you get 3?
5 minutes is what percent of an hour? Well, I guess I would probably go like this too. Probably could work like this. Here's your percent, here's your actual. What are we doing? We're cutting an hour into minutes. We have 5 actual minutes out of a total, what's my total in an hour?
60 seconds.
60 minutes. This is 100%, right? What is this number? 5 over 60 is what? Over 100. Now that one ain't gonna work out so well, probably not. You can reduce this to 1 over 12. How do I figure that out? If a proportion or whatever doesn't work out, how do I get that answer? Somebody? Nobody?
Perfect. Cross multiply.
Let's multiply. 12 times what number is 100? I'm just going to divide 100 by 12. That is my percent. 100 divided by 12 is 8. You get 96. And like I said, we usually don't do decimals with percents because that's what I'm looking for. I just make this a fraction. My leftover is 4/12, which is 1/3. 8 and 1/3%. That's a happy number, isn't it? Best number I could come up with.
I get 4.
Interestingly enough. How many of these did you actually look in your notes for?
Not a lot.
Yeah.
I'm just trying to make a little template.
I understand that, but maybe some of them you would have got right if you would have notes or looked in your notes. Not like playing with whatever it is you're playing with. Maybe the focus could be there, sir. Somebody, how do you factor stuff out? 2x squared plus 3x. When it asks you to factor, what do you have to do? Carolyn, what do I have to do when it tells me to factor out? What do you...
Get x by itself.
No, that's solve. We're just factoring now. Because there doesn't have to be an x when you solve or factor. I mean, I know in the end, I guess you do kind of get x by itself. Somebody, what do we... Maybe you mean what it, but you're not saying that like it is. Did we get this right? Wait, what do you have to do?
You would number of variables.
Yeah. You look at both of the terms, and you say, what do they have in common that I can remove? 2 and 3, can you take some number out of 2 and 3? Well, besides 1, no. X squared and x, can you take something out?
Yeah.
They both have a x, and you need to remove that x. It's reverse distributive property, so you have a parenthesis there. If you take an x out of 2x squared, you're left with 2x. If you take an x out of 3x, you're left with a 3. That's all factoring is breaking it down into 2 things that are being multiplied together that give you that.
I need 20.
Number 20. Did you ask anybody yesterday on any of these? Did you ask anybody yesterday on these? How is 20 different than 19?
19. You have to prime factor it into
It's long.
I'm just asking, what part of 20 don't you get? Because 20 is the exact same type of problem. Is there something different here that you don't?
No.
You're just going to do the same thing as prime factorize. The square root of 9 times the square root of 2, and the square root of 9 is the square root of 3 times the square root of 3. 2 identical square roots go away and give you a normal number. This doesn't have anything to go with, so it stays the square root of 2. Same type of problem, solved the same way. That's generally how these things work. This figure illustrates a triangular prism. Is that what they're asking? Brand,
How do you get over 6?
number 6. Well, I guess I would write down the formula for the area of a parallelogram, which is
Base capital B.
what?
Capital B.
No, that's volume of a prism. Area of a parallelogram. So you look at your notes. Somebody, area of a parallelogram. Evelyn?
Base and height.
Base times height. And then I have to know what parallelogram I'm talking about. A, B, C, D. A, B, C, D. This is the area I'm looking for. What's the first question I ask myself at this point? Abram?
What's the height?
Sure. And to answer that question, I have to know what? What am I looking for? When I'm looking for base and height, what am I looking for, huh? You are looking for that little corner they draw. Do you see the little square corner they put in the thing? Right, you don't see a square corner anywhere? Where is it? Right. The two lines that make that square corner are your base and your height. This line, 12. This line, 12. Base times height, 144 inches squared. Whatever lines form that, if you're looking for base and height, 12 and 12. Doesn't get any easier than that in my proverbial math book. Remember, if math were easy, everybody would do it. No, wait, if math was fun, everybody would do it. Oh, wait a minute. Everybody does do it. Carter?
What was the answer to 18?
Number 18 is 3x over 2y cubed. 3x over 2y cubed. Would you like to do it?
No, I got it.
Let's see what we actually did in all this. Direct variation, triangle, area, trapezoid. I'm guessing you have written down the area of a trapezoid, 1/2 base 1 plus base 2 is height. The area of a triangle is 1/2 base times height. I wouldn't know why you would not use some notes to help you on there. Sketch that. Find the 50th term. Nobody has issues on 13. 16 cross multiplication. Everybody got 15 right, huh? No other questions on that? Parker?
What was 15?
15 was 4. Going once? Going twice?